here is going to be a little lesson on how to convert from the log version of something to the exponential version of something. Anytime we have a problem, of course we need to start by reading our directions. So here we're asked to solve these problems without using a calculator. And off to the side, I'm going to write down the key formulas that I'm going to be using. So whenever we have something like log base 10 of x equals to y, this is equivalent to 10 to the y is equal to x. Okay? This is a formula you need to know forever and ever and ever and ever and ever. Whenever I say that base number, that's that number down here. So whatever's down here in this equation is right here in this equation. So basically you take this base number, raise it to the power of y, and set it equal to x, whatever's inside of your logarithm. So for this example, whenever you have problems like this, it's helpful to start by setting it equal to y, so then we can find which equation it looks like. And I notice that it looks like this equation right here. And I can't do just basic logarithms in my head. It's really helpful to set them up using the alternate version of the equation. So whenever you write it like this, your log goes away. So I'm going to have 10 to the y is equal to 100. And be careful, this is the power of y, not 10 times y. So whenever I have my equation in this form, my goal is to set up the right-hand side so that I have it looking like something in the left-hand side. So that means I want it to be 10 to the power of something. So I remember that 100 is 10 times 10, which can be written as 10 to the power of 2. So on the left-hand side I have 10 to the y, and on the right-hand side I have 10 to the 2. Now that they're in the similar form, I can just set it up and solve the exponents equal to each other. So y is equal to 2. And that's back to our original equation. So that's our answer. I'll do a more challenging example for part D. Same steps as before. Sorry, I got that out of our view. Okay, so same steps as before. I'm going to set it equal to y. And I'm going to set it up using this form of the equation. So I have 10 to the y is equal to 0.0001. Just as a refresher, this is our tens place, this is hundreds, this is thousands, and this is the 10,000s place. So 0.0001 is equal to 1 divided by 10,000. So once I'm here, the reason I did that is because I'm trying to get closer to having this right-hand side look like 10 to the power of something. That way I can solve for my y. So I'm going to go and just off to the side to refresh my memory. So 10 to the power of 2 is 100. 10 to the power of 3 is 1,000. 10 to the power of 4 is 10,000. Okay? So it's really helpful to have those just kind of in the back of our minds. So I'm going to replace 10,000 with 10 to the power of 4. I still don't have exactly what I want because my 10 to the power of something is in the bottom of this fraction. But there's a rule. There's a rule with exponents. Whenever you have 1 over a number to the power of a number, so 1 over x to the a is the same thing as x to the negative a on top. So you can bring it on top, but just do your exponent as a negative. So I'm going to rewrite this as 10 to the negative 4. So now I have 10 to the y on the left and 10 to the negative 4 on the right. So my y is equal to negative 4. And I'm done. I'll move on and do these examples here. So here we're allowed to use a calculator. We're allowed to use a calculator for these examples. So in your calculator, there's a button that looks like e to the x, I believe. Let me double check. Oh, no, it's going to be the 10 to the x button. Excuse me. So it's the 10 to the x button. And in baby blue print above that is the word log. Okay, so that's how we're going to do these in our calculator. Before we do it in our calculator, we need to make sure we know what exactly is being solved for here. Okay, this is really, really important. I don't want us to just plug into the calculator. I want us to be able to write down the equation too. So here, I would set it equal to y, just like before, and do 10 to the y is equal to 5. Okay, so I want us to keep that in the back of our minds whenever we plug into the calculator. So in my calculator, let me zoom in. I have to do the control key because the log is in baby blue, so you need to type in your base, which is 10, and we're taking the log of 5, so that 5 goes inside parentheses, and I push enter and see that it's 0.699. So here y is equal to 0.699. And just as a double check, y should satisfy this equation right here. 10 to the power of 0.699 is equal to 5. So I'm going to double check. 10 to the power of 0.699, and I'm going to plug it into my calculator. 10 to the power of 0.699, and I'm good. 10 to the power of 0.699 equals 5, so my double check worked out. So it's really important. I want you to write down this equation every time you're using your calculator to solve for a log.